For designing and simulating electronic circuits on Windows, several software options exist, spanning free and open source to commercial offerings. Firstly, KiCad is a professional-grade suite that is free and open source. It provides tools for schematic capture, printed circuit board, or PCB, layout and simulation. KiCad boasts a vast library of symbols and advanced features suitable for a wide range of electronic design projects. Secondly, LibrePCB is another free and open source option. It stands out as user-friendly and extensible PCB design software. It also has a comprehensive symbol library to get you started. Thirdly, OpenSCAD is a free and open source 3D modeling software. It can be used to create circuit diagrams, but it might be more suited for visual representations rather than detailed electrical designs. In terms of commercial software, firstly, Altium Designer is an industry-leading suite for professional circuit design and manufacturing. It includes a comprehensive symbol library, advanced PCB layout capabilities, and simulation tools. It is known for its powerful features and is widely used in the electronics industry. Secondly, CAD is another top-rated PCB design software with a wide selection of symbols. It offers a comprehensive set of tools for circuit design, simulation, and analysis. Thirdly, Cadence Allegro is a high-performance PCB design software used by major electronics companies. It includes a vast library of custom symbols and advanced features for complex designs. Fourthly, DipTrace is an affordable and user-friendly PCB design software with a large symbol library. It is suitable for both beginners and experienced designers. Fifthly, Eagle, now part of Autodesk, is an intuitive and popular PCB design software with a dedicated symbol library for electronics. It offers a user-friendly interface and is widely used in the maker community. All the mentioned software solutions offer extensive symbol libraries that cover a wide range of electronic components. These libraries typically include resistors, capacitors, transistors, integrated circuits or IC connectors, and other commonly used components. Having a comprehensive symbol library is essential for efficient schematic capture and circuit design. Schematic capture tools are designed for drawing electrical schematics, including wires, connectors, and all necessary symbols. These tools provide a graphical interface for creating circuit diagrams and connecting components. PCB layout capabilities are also included, especially for some software, for example Altium Designer or CAD and Cadence Allegro. These capabilities allow you to design the physical layout of the circuit board, placing components and routing traces. Simulation and analysis tools are available in KiCad and some commercial software. These tools enable you to simulate the behavior of your circuit and analyze its performance. Simulation can help identify potential issues and optimize the design before prototyping. Documentation generation features allow you to export schematics and layouts to various formats for documentation purposes. This is essential for creating manufacturing files, assembly drawings, and other documentation required for production. When selecting a program for drawing circuit diagrams, consider factors such as your budget, the complexity of your designs, and your specific requirements. Free and open source options like KiCad and LibrePCB are excellent for hobbyists and smaller projects. Commercial software like Altium Designer or CAD and Cadence Allegro offer advanced features and capabilities for professional use. Regardless of the software you choose, be sure to familiarize yourself with its features and capabilities to maximize its potential. Consider the importance of a comprehensive symbol library, efficient schematic capture tools, PCB layout capabilities, and simulation features to create accurate and effective circuit diagrams and PCB designs. Before choosing a specific software package, explore the available tutorials, documentation, and community support resources. This can help you learn the software quickly and troubleshoot any issues that may arise during the design process. Additionally, consider the software's compatibility with other tools and file formats that you may need to use in your workflow. Different software packages may have different strengths and weaknesses, so it's important to choose one that aligns with your specific needs and skill level. Start with the free trials or community editions of the software to get a feel for the interface and functionality before committing to a paid license. Keep in mind that the learning curve can vary depending on the complexity of the software, so be patient and persistent as you learn the ropes. With practice and dedication, you'll be able to create professional quality circuit diagrams and PCB designs using the software of your choice. When designing circuits and laying out PCB, it's crucial to adhere to industry standards and best practices. This ensures that your designs are reliable, manufacturable, and safe. Some important considerations include proper component placement, signal routing, and grounding techniques. Component placement involves strategically positioning components and the PCB to minimize signal interference and optimize thermal performance. Signal routing involves carefully routing traces to minimize signal reflections, crosstalk, and voltage drops. Grounding techniques involve creating a solid ground plane and connecting all ground points to ensure a stable and low impedance ground reference. Additionally, it's important to follow design rules and guidelines specified by the PCB manufacturer. These rules typically cover minimum trace widths, spacing requirements, and via sizes. Adhering to these rules ensures that the PCB can be manufactured without issues and that the circuit will function as intended. Regularly review and update your designs based on feedback from experienced designers and manufacturers. This can help identify and correct potential issues before they become costly problems. Consider using simulation tools to verify the performance of your circuit before prototyping. This can save time and money by identifying and correcting design flaws early on. By following industry standards and best practices, you can create high-quality circuits and PCB that meet your requirements and perform reliably. Remember to document your designs thoroughly, including schematics, layout files, and bill of materials. This makes it easier to collaborate with others, maintain your designs over time, and troubleshoot any issues that may arise. Additionally, consider using version control software to track changes to your designs and easily revert to previous versions if needed. Version control can also facilitate collaboration among multiple designers working on the same project. When working with electronic components, be sure to handle them with care and follow proper handling procedures to avoid damage. Electrostatic discharge, or ESD, can damage sensitive components, so it's important to use ESD-safe workstations and grounding straps. Additionally, be sure to use appropriate soldering techniques to ensure reliable connections and avoid overheating components. Overheating can damage components and cause them to fail prematurely. Consider using a temperature-controlled soldering iron to maintain a consistent soldering temperature and prevent overheating. When selecting components, be sure to choose parts that meet your performance requirements and have appropriate ratings for voltage, current, and power. Additionally, consider the availability and cost of components, as well as their lead times. Selecting readily available and affordable components can help reduce project costs and shorten development time. By following proper handling procedures and selecting appropriate components, you can ensure the reliability and longevity of your electronic circuits. When troubleshooting electronic circuits, it's important to have a systematic approach and use appropriate tools. Start by visually inspecting the circuit for any obvious issues, such as broken wires, loose connections, or damaged components. Then use a multimeter to measure voltages, currents, and resistances at various points in the circuit to identify any anomalies. If you suspect a specific component is faulty, you can try replacing it with a known good component to see if that resolves the issue. Additionally, consider using an oscilloscope to visualize signals and identify any timing issues or signal distortions. When troubleshooting complex circuits, it can be helpful to divide the circuit into smaller sections and test each section independently to isolate the problem. Also, be sure to consult the circuit schematic and documentation to understand its intended operation and identify any potential sources of error. By following a systematic approach and using appropriate tools, you can effectively troubleshoot electronic circuits and resolve any issues that may arise. In addition to the software options mentioned earlier, there are also online tools and resources available for creating circuit diagrams and simulating circuits. These online tools can be convenient for quick designs and simulations, but they may not offer the same level of features and capabilities as desktop software. Some popular online circuit simulation tools include CircuitLab, EasyEdda, and Tinkercad. These tools allow you to create schematics, simulate circuits, and analyze their performance directly in your web browser. They also offer libraries of common electronic components and support various simulation models. Additionally, there are online resources available for learning about electronics and circuit design. These resources include tutorials, articles, forums, and online communities where you can ask questions and get help from experienced designers. Some popular online resources for electronics learning include All About Circuits, Electronics Tutorials, and the Arduino Forum. By utilizing online tools and resources, you can supplement your knowledge and skills in electronics and circuit design and create innovative and effective electronic circuits. When working with high voltage or high current circuits, it's crucial to take appropriate safety precautions to prevent injury or damage. Always disconnect the power supply before working on a circuit and discharge any capacitors to avoid electric shock. Use insulated tools and wear safety glasses to protect yourself from potential hazards. Additionally, be aware of the potential for fire hazards when working with electronic circuits and keep flammable materials away from heat sources. If you're not comfortable working with high voltage or high current circuits, it's best to seek assistance from a qualified electrician or electronics technician. Always follow safety guidelines and best practices to ensure a safe working environment. When designing and building electronic circuits, it's important to consider the electromagnetic compatibility, or EMC, of your designs. EMC refers to the ability of a circuit or system to function properly in its intended electromagnetic environment without causing interference to other devices or being susceptible to interference from other devices. To ensure good EMC performance, it's important to follow best practices for grounding, shielding, and filtering. Grounding involves creating a low impedance path for return currents to minimize noise and interference. Shielding involves enclosing sensitive circuits in a conductive enclosure to block electromagnetic radiation. Filtering involves using passive or active filters to attenuate unwanted signals and noise. Additionally, it's important to comply with relevant EMC standards and regulations such as the Federal Communications Commission or FCC regulations in the United States and the European Union's EMC directive. By following EMC best practices and complying with relevant standards, you can ensure that your electronic circuits and systems operate reliably and without causing interference to other devices. When designing electronic circuits for specific applications, it's important to consider the environmental conditions in which the circuit will operate. Environmental conditions such as temperature, humidity, vibration, and shock can affect the performance and reliability of electronic components. To ensure reliable operation in harsh environments, it's important to select components that are rated for the appropriate temperature range, humidity levels, and vibration and shock levels. Additionally, it may be necessary to use conformal coatings or enclosures to protect the circuit from moisture, dust, and other contaminants. Consider using ruggedized connectors and cables to withstand vibration and shock. By considering the environmental conditions and selecting appropriate components and protection measures, you can ensure that your electronic circuits operate reliably in demanding environments. When designing electronic circuits for battery-powered applications, it's important to consider power consumption and battery life. Power consumption can be minimized by using low-power components, optimizing circuit design, and implementing power management techniques. Low-power components include microcontrollers, memory devices, and analog components that are designed to operate at low voltages and currents. Circuit design optimization involves minimizing the number of components, reducing trace lengths, and using efficient power conversion techniques. Power management techniques include sleep modes, clock gating, and dynamic voltage and frequency scaling. By minimizing power consumption and optimizing battery life, you can extend the runtime of battery-powered devices and reduce the need for frequent battery replacements. Remember that careful planning and design are essential for creating efficient and reliable battery-powered electronic circuits.